Okay, number 4. And again, we're getting a little better at this, and I'm not saying perfect yet. No one ever gets perfect at anything. But we're looking for an upper bound on this polynomial. And the way I'm going to do is, kind of look around, and I'll try to do as, the least amount of work as possible. And I realize, I'm basically looking at integer numbers, but I'm trying to find that integer where things become overwhelmingly in a direction, all right? So at 0, I definitely know it's negative. I'll put a star over here. At 1, what would you, and it's easy. I really mean it's easy. 3 minus 5 is minus 2. It's definitely negative. I'm going to get a 2. And I'm wondering when things are going to kick in. When is the integer going to become so powerful in that 4th degree to overpower all the other terms? So if you did 2, a little more difficult. Well, it's going to be 3 times 16, which is 30 and 18, 48. That's pretty powerful, right? Minus 20, minus 16, minus 7. Right? That's positive, right? Now let's just go to 3. Just see what happens, all right? 3 times 81, not even going to do it, minus 5 times 9, minus 24, minus 7. I think you get the impression now that that 4th degree term is really taken off, all right? So what's the upper bound in that? The number 2. Let's go to the k. Again, they might put a lot of work down for that, but the bottom line is you decide what the work is going to be, right? The reason I write up a key like this is for people that are reading it, the upper limit. We're talking through it, though. Upper limits, too. Let's do the lower limit, though, all right? So it's really the same type of analysis, but we'd like to rotate the curve because it's easier in the analysis. Let me erase this business over here. We're done with that. Let me erase, it's an older picture there. Okay, we're going to rotate it. And again, remember, it's 4th degree polynomial, so we just need to rotate about the y-axis. And let's see what happens. What do you get? F of x equals 3x to the 4th minus 5x squared plus 8x minus 7. Same story. Right, a little different, though. Same thing I'm going to be doing. We're looking for positive roots now. We just rotated it. Oh, I'm sorry, this is minus x. Let me get my eraser out to make that look better. Again, we rotate about the y-axis, right? Makes it easier analysis. At 0, it's still negative. At 1, what is it going to be? Well, let's take a look at it at 1, right? So that, and again, the 4th degree term is really going to take off at some point. It'll be 3 minus 5 plus 8 minus 7. Well, 3 minus 5 is, minus 2, and yeah, we still have negative. All right, let's go to the 2. All right, let's cross this out. What are you going to get? 3 times 16 minus 5 times 4 plus 16 minus 7. I want to point out, this is where things become at least in my opinion, obvious that it's going to keep going up at this point. All right? So what's the lower bound now? The lower bound is minus 2. Let's take a look at that. See if they put that down. Yep, lower bound is minus 2. Whoops, I got a mistake there. Go backwards. Let's look at the picture, though. Figure 314. Did I put 314 down twice already? Oh, no, I'm sorry. It's 313. We're looking at 314. Wow, we did it right. All right, upper bound we said was 2. Lower bound we said is minus 2. We did it right. Got those integers going, all right? Integer analysis, so to speak, all right? It's important you have a sense of this. Again, the pictures are here to help us support our sense. It's nice to have a picture to support what we believe. Thank you. Oh, before I go, my name is Ron Bannon. Email address, Bannon, B as in boy, the @ symbol, NNON.US. All right? Thank you.